When the product is turned on, the machine will automatically set to easy mode where by pressing the knob, I can adjust the necessary welding current. The display will show the indicative thickness of the piece to be welded, as well as the suggested electrode diameter and the required gas flow rate. Additionally, on the front of the machine, I will find other buttons, the first of which will allow me to switch to Pro mode, the menu for selecting the welding arc, gas purge, and saving custom programs, as well as the general settings of the machine. Let's now look at the settings for selecting the welding arc. By pressing the menu button, I will have access to various setting options. The first menu indicates the welding mode of the machine, where I can choose between TIG with high frequency, TIG with non-high frequency ignition, TIG with high frequency and pulsed, TIG with lift ignition without high frequency and pulsed, and electrode and pulsed electrode mode. Additionally, I can set various welding settings in AC or DC or mix AC-DC. AC welding is necessary for welding aluminum alloys and sometimes bronze. DC welding is necessary for welding steel, stainless steel, titanium, brass, while mix AC-DC is a particular function dedicated to welding thick aluminum or to increase the speed of joint execution. In DC mode, continuous current welding, I can then select the polarity inversion of the machine's front sockets through this menu by selecting whether I want the torch to be negative or positive. In addition to the push, I can select the button press modes. 2T, where pressing the button starts welding and releasing it ends the welding. 4T, where by pressing the torch button and releasing it immediately, I will continue to weld without having to hold the torch button. To finish the welding, I will have to press and release the torch button again. 4T bi-level, where in the same way as before, I will press the torch button and release it immediately to start welding. At that moment, I can call up a second welding current, usually lower than the main one, simply by pressing and releasing the torch button quickly. Just press and release the torch button quickly again to return to the main current. To turn off the arc, as in standard 4T mode, just hold the torch button slightly longer and then release it. We also have the spot welding modes with a set time in 2T and 4T. Let's now look at the standard DC welding modes. Activate Pro mode. In this mode, the complete welding waveform with all essential parameters appears. Let's look at them one by one. The first parameter is the pre-gas time, which is the time the gas exits the torch before the welding current arrives. This is necessary to protect the weld pool from possible inclusions. The start time. This time allows identifying a time for which the machine will deliver a higher ignition current than the main welding current. Once the start time is set, it can return to the start current, and I will indicate what its value will be. A ramp that will take me from the start current to the main current. If this ramp is off, once the start time is over, the machine will instantly switch to the main current, or by setting a ramp time. The machine will move from the start current to the main current I2, descending in that time. Main current. This is my actual welding current that I will need to identify based on the piece I will be welding. Main current descent ramp. At this moment, we begin the closing phase of the welding and the final phase. In this case too, I can set a time for which the machine will move from the main current I2 to the final end current. Or if left off, it will switch directly to the end current sharply. End current time. After passing from the main current through the ramp, I can indicate a time for which the welder will maintain a certain final current. It is also called crater filler, given the need to close the weld without the final crater that could generate cracks in the weld. In addition to the time of this current, I will obviously also indicate the value of its current. At the end of this, we find the post gas, which is the gas that continues to exit the torch once the welding arc is off, and still serves to protect the piece and ensure the cleanliness of the electrode for the next ignition. Let's now add the pulse mode. Activate Tig HF pulse mode. To do this, press the menu and select the Tig HF pulse mode. Press the OK button to confirm. At this moment, we see that the pulse function is added to the previous waveform. The previously explained parameters remain exactly the same, but in the pulse icon, I can adjust a secondary pulsing current. The frequency with which this current will exchange with the main current up to 400 Hz, and the balance between the main and secondary current. The balance indicates that if I am at 50%, I will actually have 50% of the time the first current and the remaining 50% the second current. If I vary, I will vary the percentage of the first current compared to the second. As always, by pressing the knob, I confirm these values. Let's now look at the AC welding mode for aluminum. Press the menu button and set the AC mode, and at this moment the machine proposes the selection of the AC waveform. In this product, I can select 3 types of waveform. The first AC square waveform, where the waveform has a square wave character, very energizing towards the piece, but with a slightly nervous arc. There is also the AC optimize mode that eliminates the restlessness of the square waveform and reduces its noise, approaching that of the sinusoidal waveform. We also have the AC sinusoidal waveform, very smooth in welding, but transferring less energy to the piece. Let's set the AC optimize waveform. Select it. As before, I can select the 2 times, 4 times. Once the desired mode is selected, I will press the OK button. Here appears the waveform for selecting the parameters for the AC. New icons appear on the display. Let's look at them. Let's start from the first icon at the bottom left. It is always the pre-gas, as explained before. It is the gas exit time before welding, the start time and its current, the ramp to the main current, the descent ramp, the end time, the end current, and the post-gas. In addition to this, I will in this case adjust the pulse current, its frequency, and its balance. In the AC menu, I will adjust the exchange frequency between the positive and negative current. This is the frequency adjustable from 10 to 250 Hz. Additionally, we will adjust the balance of the positive current compared to the negative current. The more positive current I have, the more cleaning of the piece I will have, but more electrode consumption. The electrode will therefore be more stressed, and the display shows it in red. More negative current will correspond to greater fusion of the piece and less cleaning of the piece. That is, the piece will heat up more. It is customary to use a greater negative balance to have greater penetration and faster welding speed. The default advice is still to weld at 0, that is, 50% of one and the other. In addition to this, in AC mode, I will have to select the diameter of the electrode mounted on my torch. This is an important parameter because it allows me to start with very low currents, even with very large diameter electrodes. By pressing the knob, I will adjust the electrode diameter through commonly used diameters: 1, 1.6, 2.4, 3.2, and 4 millimeters. In addition to this, I can correct the energy for each diameter to better avoid or customize the ball that forms at the beginning of the weld on the electrode to better stabilize the arc. Let's set the machine in MMA. Press the menu button and select the electrode option in MMA. Press the OK button to confirm. At this moment, the machine automatically turns on the cooling fans. This is the welding waveform for coated electrode welding. Let's look at each parameter starting from the first. VRD, voltage reduction device. This is a function that can be activated or deactivated, where if I activate it, the machine's open circuit voltage automatically lowers, significantly reducing the risk of possible electric shocks in high-risk environments. In the most common mode, this is off. We also have the hot start option, where it is possible to indicate a starting overcurrent for the electrode to make the arc strike more easily. Here, I will adjust the current percentage on the main current. If, for example, the main current is 100 amperes and the hot start is set at 50%, then the resulting hot start current will be 150 amperes. Main welding current. By adjusting this current, I will adjust the current based on the diameter and type of electrode I will use. The machine displays a suggested electrode diameter for the set current, mainly designed for rutile electrodes. Arc force. The arc force is a correction, also in percentage, that allows the machine to help keep the arc lit during the welding movement. It is a percentage of the main current. During hand movement, the machine senses the welding voltage, and if the electrode tends to stick to the piece, it will give me an overcurrent to move away. Conversely, if I tend to stay away from the piece with my hand, the machine will tend to keep the voltage stable to keep the arc lit. Let's now call up the MMA pulsed mode. Press the menu button, select the MMA pulsed mode, press the knob, and confirm with OK. In this case, too, we have the same parameters used previously, so the VRD, hot start, main current, and arc force. But in addition, we have the pulsed settings where, by pressing the knob and selecting this option, we can indicate the second pulse current that must be higher than the first. The pulse frequency, the alternation of the first current and the second current, and the balance of the first current compared to the second. This functionality is very useful for welding on vertical, ascending, or descending welds or overhead. Let's now look at the job menu. Within the job menu, we find the possibility to save, recall, delete, export, and import personal welding programs, and there is also the general machine settings menu. Let's first look at the saving possibilities. Entering the job menu and pressing the save icon, I can name my welding program, saving all those options we changed before in the curve, where we set all the parameters. Then going to the recall icon, I can find my welding programs and can then recall my program on display. I can then delete the programs simply by recalling and confirming the deletion, or if I want, I can export a welding program to a USB stick to be connected to the machine's USB port, which I can then import to a third machine. In addition to this, there is the welding data recording mode. As soon as I insert the USB stick into the machine, the recording mode activates automatically. From this button, I can then stop the welding data recording and then restart it at a later time. In the Machine Settings menu, I will find the Product Setup menu where I can select the language of the information on display, time and date, metric or imperial system, and machine name. The machine name is useful when I need to save welding data, as I might have different machines and need to know which machine performed a particular job. In addition to this, I can enter the Product Service menu. In this menu, I will have the possibility to find various information. First, the life hours the product has, that is, how long the machine has been on, how many hours the machine has actually welded, the list of alarms the machine has recorded, and the product serial number. Additionally, I can perform a software update. The software must be saved on the USB stick, and once inserted into the USB port, I can generate the update by simply pressing the update button. I can then reset the product to factory condition and check the software release installed on the machine. In addition to this, a very important function for service, I can generate a report file that will be saved on the USB stick where all the product information and some test points within the boards will be saved to facilitate the diagnosis of any problems. On the front of the machine, we have the control connector, the gas outlet connector, the positive power socket, and the negative torch socket. On the front of the cooling unit, we have the fluid supply and return, the tank refill cap, and its level indicator. On the back of the generator, we have the remote control socket, the cooling unit power socket, the cooling unit protection fuse, the product data plate, the welding gas inlet fitting, the power cable, and the product on-off switch.